A short review on effective dairy wastewater treatment techniques. Abstract: tremendous growth in size and number in most countries of the world have been monitored towards dairy industries. High chemical oxygen demand, COD, biological oxygen demand, BOD5, nutrients, and other pollution loads are indicators used for characterization of the effluent. Increased attention for research has been dedicated to reducing the harmful impact of these industries. This review paper discusses the recent treatment technologies of dairy wastewater briefly. Biological treatment like backed bed filters and biofilms and advanced oxidation processes like electrocoagulation and electro-Fenton are examples of reliable treatment methods in degradation of dairy wastewater. In fact, selection of an effective dairy wastewater treatment technology is difficult because of the highly variable nature of dairy wastewaters. To emphasize the appliance of each method, the merits and limitation are displayed. Keywords: dairy wastewater, advanced oxidation processes, biological treatment. Abbreviations: DW, dairy wastewater, COD, chemical oxygen demand, BOD5, biological oxygen demand, HRT, hydraulic retention time, AOPs, advanced oxidation processes. Introduction. The increased milk demand with the increase in population enlarges the amount of wastewater produced from dairy industrial operations. Moreover, the effluent from industrial dairy wastewater is considered one of the largest sources of industrial effluents. 1. Boiling plants, cheese plants, and butter and dried milk plants are regarded sources of dairy wastewater. Dairy waste streams may cause dangerous problems because these effluents contain organic matter of high concentrations. The discharge of dairy wastewater, DW, can result in environmental problems. Physicochemical and biological treatment methods were used to treat DW, such as electrocoagulation, electro-Fenton, biofilms, and backed bed filters. 2-4. In order to decrease the harmful effects of dairy wastewater on environment, it is preferable to choose suitable techniques. 5. Consequently, recent research is focused on investigating highly effective methods on treatment of dairy wastewater. 6. This review paper aims at concisely presenting some recent advances of various technological methods that have been reported for treatment of dairy wastewater with removal efficiency and exploring new successful substitutional processes for treatment of dairy wastewater influentially. 2. Discussion. A. Biological treatment. Biological methods can be considered one of the most favorable technologies for the removal of organic matter from dairy wastewater because dairy wastewaters are highly biodegradable. Furthermore, they have the ability of combining different types of biological schemes and are still fairly unsophisticated. 7. Javid Iqbal Qazi et attained maximum percentage removal of 96%, 93% and 90% of COD, BOD5 and VSS using batch reactor filled with gravels with application of 21 kg COD/M3/D loading. Additionally, 89% reduction of volatile suspended solids, VSS, were obtained after 12 days hydraulic retention time, HRT, in each cycle of repeated batch. Indrajit and Yadav. 9. Experienced the performance of packed bed bioreactor in batch and continuous process for treatment of DW. The best result achieved was 83% COD removal efficiency at 26 HRT and an airflow rate of 1 RPM. Ileana Mayla Maria and Moreno Davila et al. 10 tested the hydrogen production in packed bed batch reactors and evaluated the operational conditions of her hydrogen production from dairy wastewater. The authors found out that maximum hydrogen production obtained was 12.73 mm H2/G COD when initial COD concentration was 21.1 grams COD, dairy wastewater pH with no adjustment and room temperature of 16 ± 3 degrees Celsius. The key limitation of biological treatment methods is the formed sludge, especially during the aerobic biodegradation processes, may cause serious and costly disposal problems. B. Advanced oxidation processes, AOPs. Advanced oxidation processes, AOPs, prove as promising methods in destructions most of organic and inorganic matters by converting them into benign end products such as CO2 and H2O11. Many researchers frequently employ AOPs since they provide many potential processes for hydroxy radicals production, which are one of the most powerful oxidants that able to oxidize many organic compounds to CO2 and H2O and inorganic ions. 12. In addition, electrochemical methods like electrocoagulation and electro-Fenton processes which based on the electrogeneration of hydroxy radical, are eco-friendly processes which have attracted great attention for water treatment. 13. Additionally, electricity used in the process is considered a clean source of energy, so they do not create secondary pollutants. Add to that, they adapt to the environmental conditions for water and wastewater treatment because they do not cause any harmful reagents. 14. Electrocoagulation has been experienced by many. IJERT 9 is 070456 www.ijert.org. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by International Journal of Engineering Research and Technology, IJERT. www.ijert.org ISSN 2278-0181. Volume 9 Issue 07, July 2020. Researchers in it has highly achieved removal efficiency for many contaminants. 15. Shivaya Jimith et al. 16 reported that 98.75% COD and 97.82% turbidity can be removed at applied voltage of 7 V and pH 6 within 10 minutes. Another study revealed that removal efficiency of the COD and oil grease was raised to 98 and 99%, respectively. The optimal current density was 0.6 mA/cm2 within 1 minute, the electrode consumption was 0.0204 grams electrode/kg COD removed, and the power requirement were 0.003 kWh/kg COD. 17. Electro-Fenton has received high attention due to its highly contribution to remove various recalcitrant organic compounds. 18. Devarnajad et al. 19 investigated the performance of electro-Fenton process for organic compound degradation in dairy wastewater effluent and found that 93.24% COD removal could be obtained at operational conditions of current density of 58.5, pH value of 7.58 H2O2/Fe2 plus molar ratio of 3.62 and volume fraction of H2O2 to dairy wastewater of 1.39 ml/L within 87.13 minutes. The high amount of produced sludge limits the application of Fenton processes, but their high efficiency and low cost make them preferable. 3. Conclusion. This review paper aimed at presenting some of the available treatment methods for dairy wastewater briefly. All previous aforementioned treatment methods need to be hybrid with conventional effluent treatment plant with tertiary treatment due to variation in quality and quantity of dairy wastewater. Although there are some limitations about the application of the above-mentioned methods, it is concluded that biological treatment methods like packed bed filters and biofilms and advanced oxidation processes like electro-Fenton and electrocoagulation treat dairy wastewater effectively.